The National Electrical Code (NEC) requires that busing and circuit breakers have the same ampere interrupting capacity (AIC) rating according to NEC sections 240.83 E and 240.85 D. It is permissible to install 65 kA interrupting capacity or 65 AIC rated breakers into a 50 kA interrupting capacity or 50 AIC rated enclosure if specific conditions are fulfilled. The available fault current must not surpass the AIC rating of the enclosure busing, which in this case is 50 AIC. Furthermore, the busing must be braced to endure a fault current of at least 50 AIC. In such a scenario, the AIC rating of the enclosure busing serves as the limiting factor. This is because the busing constitutes the weakest link in the circuit and must possess the capability to withstand the maximum fault current that may arise. The breaker AIC rating should be equal to or exceed the AIC rating of the busing. Employing a breaker with a higher AIC rating than the busing is unnecessary and will not provide supplementary protection. The compatibility regulations are in place to guarantee the secure operation of the system under fault conditions. If the AIC rating of the busing falls below that of the breaker, the busing may fail during a fault, leading to potentially catastrophic damage. In conclusion, while the installation of higher AIC-rated breakers into a lower AIC-rated enclosure is feasible, it is imperative to take into account the available fault current and the bracing of the busing. The AIC rating of the enclosure busing defines the limits of the breaker that can be utilized. The selection of circuit breakers for electrical panels and switchboards necessitates a thorough understanding of AIC ratings and their compatibility with the equipment's busing. The AIC rating signifies the maximum fault current that a circuit breaker can safely interrupt without sustaining damage or posing a safety hazard. When integrating circuit breakers into an electrical system, it is paramount to ensure that their AIC rating meets or surpasses the available fault current at the point of installation. This precaution guarantees the circuit breaker's ability to effectively clear faults and prevent extensive damage to the electrical system. Busing, which refers to the conductive bars or strips within an electrical panel or switchboard, serves as the pathway for electrical current distribution. Busing possesses its own AIC rating, indicating the maximum fault current it can withstand without experiencing structural failure or compromising its functionality. Consequently, the AIC rating of the busing emerges as a critical consideration when choosing circuit breakers for installation within the enclosure. The National Electrical Code, or NEC, stipulates that the AIC ratings of circuit breakers and busing must be coordinated to ensure the system's safety and reliability. Specifically, the NEC mandates that the AIC rating of a circuit breaker must not exceed the AIC rating of the busing to which it is connected. This requirement aims to prevent the installation of circuit breakers with interrupting capacities that surpass the busing's ability to withstand fault currents. By adhering to this guideline, the risk of busing failure during fault conditions is mitigated, thereby safeguarding the integrity of the electrical system. The AIC rating of the enclosure busing serves as the limiting factor in determining the appropriate circuit breakers for installation. This principle stems from the understanding that the busing represents the weakest link in the circuit and must be capable of withstanding the maximum fault current that may occur. In other words, the circuit breakers installed within the enclosure must possess an AIC rating equal to or lower than that of the busing. Attempting to install circuit breakers with AIC ratings exceeding the busing's capacity can lead to hazardous situations. During a fault, the excessive fault current may overwhelm the busing, resulting in physical damage, arcing, or even complete failure. Such an event can trigger a catastrophic electrical failure, endangering personnel and property. While employing circuit breakers with AIC ratings higher than the busing might seem like a prudent approach, it offers no additional protection and can potentially introduce safety risks. The circuit breaker's interrupting capacity is limited by the busing's ability to withstand fault currents. Consequently, installing higher rated circuit breakers does not enhance the system's overall protection level. The compatibility rules governing AIC ratings are rooted in the fundamental principle of ensuring the system's safe operation under fault conditions. These rules are designed to prevent the failure of system components and minimize the risk of electrical hazards. By adhering to these guidelines, electrical engineers and technicians can create systems that effectively mitigate the dangers associated with fault current. In practical terms, selecting circuit breakers for an electrical panel or switchboard entails a systematic approach. Firstly, the available fault current at the point of installation must be determined through calculations or engineering studies. This value represents the maximum fault current that the circuit breakers will be expected to interrupt. Secondly, the AIC rating of the enclosure busing must be identified. This information is typically found on the equipment's nameplate or technical specifications. Thirdly, circuit breakers with AIC ratings equal to or greater than the available fault current, but not exceeding the AIC rating of the busing, should be selected. This selection process ensures that the circuit breakers can safely interrupt faults without compromising the integrity of the busing. In situations where the available fault current exceeds the AIC rating of the existing busing, several options can be considered. One approach involves upgrading the busing to a higher AIC rating, thereby accommodating the higher fault current levels. Another option entails implementing current-limiting devices, such as current-limiting fuses or circuit breakers, to reduce the magnitude of the fault current. These devices effectively limit the fault current to a level that the existing busing can safely withstand. Adherence to the compatibility rules regarding AIC ratings is paramount for ensuring the safe and reliable operation of electrical systems. By carefully coordinating the AIC ratings of circuit breakers and busing, the risk of catastrophic failures and electrical hazards can be significantly reduced. The National Electrical Code (NEC) provides comprehensive guidelines on these requirements, and it is essential for electrical professionals to be well versed in these standards. The ampere interrupting capacity, or AIC, rating of electrical equipment is a crucial parameter that indicates its ability to safely interrupt fault current. When selecting and installing circuit breakers in electrical panels and switchboards, it is imperative to ensure that their AIC ratings are compatible with the busing system to which they are connected. Failure to adhere to these compatibility requirements can result in equipment failure, electrical hazards, and potential safety risks. The National Electrical Code, or NEC, establishes specific guidelines for coordinating AIC ratings between circuit breakers and busing. These guidelines are intended to safeguard electrical systems and personnel from the dangers associated with fault currents. Understanding and complying with these NEC requirements is essential for electrical engineers, technicians, and contractors involved in the design, installation, and maintenance of electrical systems. The fundamental principle underlying AIC rating compatibility is that the circuit breaker's AIC rating must be equal to or greater than the available fault current at the point of installation, but not exceed the AIC rating of the busing. This principle ensures that the circuit breaker can safely interrupt fault currents without compromising the integrity of the busing system. The available fault current is the maximum current that can flow during a short circuit or ground fault condition. It is determined by factors such as the source impedance of the electrical supply, the transformer capacity, and the impedance of the conductors. Electrical engineers typically perform fault current studies to calculate the available fault current at various points in the electrical system. The busing system, which consists of conductive bars or strips, serves as the backbone for distributing electrical current within the panel or switchboard. Busing has its own AIC rating, indicating the maximum fault current it can withstand without sustaining damage or failing. The AIC rating of the busing is typically specified by the equipment manufacturer and should be clearly marked on the equipment's nameplate or technical documentation. When selecting circuit breakers for installation in an electrical panel or switchboard, it is crucial to consider both the available fault current and the AIC rating of the busing. The circuit breaker's AIC rating must be high enough to safely interrupt the available fault current, but it should not exceed the AIC rating of the busing. Installing circuit breakers with AIC ratings exceeding the busing's capacity can create a dangerous situation. During a fault, the excessive fault current may overwhelm the busing, leading to physical damage, arcing, or even complete failure. This can result in a catastrophic electrical failure, endangering personnel and property. The National Electrical Code, or NEC, provides specific guidance on the proper selection and installation of circuit breakers with respect to AIC ratings. NEC Section 110.9 addresses the interrupting rating of equipment, stating that equipment intended to interrupt current at fault level shall have an interrupting rating sufficient for the available fault current at its supply terminals. This requirement emphasizes the importance of matching the circuit breaker's AIC rating to the available fault current. NEC Section 240.86 provides additional requirements for series ratings, which involve coordinating the AIC ratings of upstream and downstream circuit breakers. Series ratings allow for the use of downstream circuit breakers with lower AIC ratings, provided that they are properly coordinated with upstream circuit breakers that have higher AIC ratings and current limiting capabilities. The series rating approach can be used to reduce the cost of circuit breakers while still maintaining adequate protection against fault currents. In addition to the NEC requirements, equipment manufacturers also provide guidance on AIC rating compatibility. Manufacturers typically publish technical bulletins and application guides that specify the recommended circuit breakers for use with their equipment. These documents provide valuable information on AIC ratings, series ratings, and other factors that should be considered when selecting circuit breakers. It is important to consult these resources to ensure that the circuit breakers are properly matched to the equipment's busing system. When evaluating AIC rating compatibility, it is essential to consider the withstand rating of the busing. The withstand rating is the maximum fault current that the busing can withstand for a specified duration without sustaining damage. The withstand rating is typically expressed in kiloamps or Ka, and is often listed on the equipment's nameplate or technical documentation. The circuit breaker's interrupting time should be less than the withstand time of the busing. In situations where the available fault current exceeds the AIC rating of the existing busing, several options can be considered. One option is to replace the existing busing with busing that has a higher AIC rating. This can be a costly and time-consuming process, but it may be necessary to ensure adequate protection against fault currents. Another option is to install current-limiting devices, such as current-limiting fuses or circuit breakers, to reduce the magnitude of the fault current. Current-limiting devices can significantly reduce the peak fault current and the duration of the fault, thereby mitigating the stress on the busing system. Current-limiting fuses and circuit breakers are designed to interrupt fault currents very quickly, typically within a few milliseconds. This rapid interruption helps to protect downstream equipment from damage and reduces the risk of electrical hazards. It is important to note that current-limiting devices must be properly coordinated with other circuit breakers in the system to ensure selective coordination. Selective coordination ensures that only the circuit breaker closest to the fault will trip, minimizing the disruption to the rest of the electrical system. The AIC rating of the enclosure busing defines the limits of the breaker that can be used. The available fault current must not exceed the AIC rating of the enclosure busing in this case. The busing must be braced to withstand a fault current of at least the maximum available. The compatibility rules ensure that the system will operate safely under fault conditions. If the AIC rating of the busing is lower than the AIC rating of the breaker, the busing could fail during a fault, potentially causing catastrophic damage.